Hi guys, welcome to Netgate Chemistry. In this video of quantum chemistry, we are going to discuss about some of the commutation relations of angular momentum. Now in the previous video we have discussed a little bit about the angular momentum, that is what is angular momentum and what is the operator which we use in the angular momentum. Now we are going to see some of the commutation relations. So first we are going to discuss commutation relations of angular momentum, again with another type of angular momentum or similar angular momentum. For example, if we have to solve the commutation for Lx and Ly, then we are going to get iota h cross Lz. Similarly, if we are going to solve for Ly Lz commutation, you will be getting iota h cross Lx. If you are going to solve Lz Lx, you will be getting iota h cross Ly. These are the generalized relations. Now, if you are going to solve the opposite of them, for example, if you want to solve Ly Lx, their commutation, then you just have to introduce negative sign because commutator operators are anti-symmetric in nature. So it will be this. Similarly, Lz Ly, it will be minus iota h cross Lx. Lx Lz, it will be minus iota h cross Ly. So here what you can observe is when you are moving clockwise, if you make a circle, again x, y and z, and if you are moving clockwise, that is x to y, from x to y, your results are positive, and when you are moving anti-clockwise, that is y to x, then results are in negative. So this way you can learn these, right? Now second relation will be angular momentum and linear momentum. So here what you will be getting, first is Lx with Py. You will be having iota h cross Pz. X, y is used up, so it will be z. This way you can learn. So this is again also going clockwise from x to y. Right? Now Ly Pz, it will be iota h cross Px, and Lz Px, it will be iota h cross Py. Similarly, if you want to find out the opposite of them, like Py Lx, so it will be just minus of iota h cross Pz. Now Pz Ly minus iota h cross Px. Px Lz, it will be minus iota h cross Py. Right? Now third type of relations are angular momentum and position. Now here we have Lx with y. So again we are moving clockwise from x to y. So it is iota h cross. See, iota h cross is everywhere when we are moving clockwise, and minus iota h cross is everywhere whenever we are moving anti-clockwise. So if you are using up x and y, then answer will be in terms of z, right? So you have to see which ones are used up, so the one which is left will be the answer. That way you can learn. So x and y are used up, so here what it will be z. Now Ly and z, so it will be iota h cross x. L, z and x, so it will be iota h cross y. Now if you want to find out the opposite of them, that is y Lx, it will be minus iota h cross z. Now z into Ly, it will be minus iota h cross x. X in and L z, so it will be minus iota h cross y. So these are some of the generalized results. So I have not solved the numericals based on these commutators, so you can solve by yourself if you have time, so you can solve each of them also. So I'm just giving you the answers to them, so you need not solve them, you just need to learn them, right? So I have also told you how you can easily learn them, right? Now there is one more property left for commutation relations, that is L square with x, or you can say any of the position vectors with x, y, z, any, that is L square with x or L square with y or L square with z, that is going to give you 0. Similarly, L square with any of the linear momentum operators px or py or pz, again it will be giving you 0. L square with any of these vx, vy, vz, again it will be giving you 0. L square with Lx or Ly or Lz will be giving you 0. Okay, so suppose if in a question they are asking you have to solve L square Ly commutation of this, so it is 0. If they are asking commutation of L square Vz, it is 0. If they are saying L square Px commutation, 0. If they are saying L square x, 0, right? So these are also the generalized relations which you can learn easily, right? So these are some of the generalized relations. Now we can go ahead and see some of more properties of commutators, right? So now we will study some of the properties of the operators, of the commutator operators. So the first property is, if we want to find out the commutation for A and B into C, these are multiplied, these two are multiplied. So how we can open them up is, first, how you can remember this, first take out B left side and then C right hand side. So first I will take out B to the left hand side and A and C will remain here, right? And then plus sign. Now C will come to the right hand side, so onto the left hand side will be left with A and B, and C will come onto the right hand side. So this is the first property which you need to learn. Now similar property, if we want to find out A and B, C, D, these three are multiplied, then what we have to do, first pair B and C, then pair C and D, then pair D and B, 3 pairings. Now what you have to do is, first we have paired B and C, so B and C will come out here and we will be left with, B and C have come out, so we will be left with A and D, right? B and C will come out to the left side, right? And then C and D will come out to the right side. B and D will come out towards left and right. How? I will tell you. So first I have taken BC to the left side, then I will take out CD to the right side. So if I take out CD, then I'll be left with A, B. So CD is coming right side. Okay. Now B and D are here and here. So what you have to do is take out B here and D here. Okay. How? B will be here and D will be here. Okay. So what we have done is, first we have taken out BC left side and CD right side. Now we are left with B and D. What we did is take out B left side and D right side. So if we take out B and D, we'll be left with A and C. So A and C will come here. This way you can learn. If this trick is not working for you, you can just memorize it, right? Now the next property is commutation of position and partial differentiation. For example, we have partial differential operator del by del x and any of the position operators. Suppose we have z. So if we are going to commute it, the answer will be 0. This is the next property. Okay. Now, next property is the property of linearity. What it says is that if we want to find out a and b plus c, their commutation, then how it can open up? It can open up a b plus a c. Similarly, if we have a plus b with c, it can open up as ac plus bc. It is just like opening a bracket, right? First you multiply this by this and then this by this. Now if you want to a plus b and c plus d, if you want to solve out commutation for this, then what you have to do is, again, just like opening a bracket in mathematics, just like that, what you have to do is, first what we will do, a into c, so it will be a c plus a with d, right? What I'm doing is first this with this and then this with this, a d. Now a is done. Now b with c and b with d, so it will be b with c and b with d. So these three are the properties of linearity. So for example, in a question they have given you x, that is position, and h, that is Hamiltonian, and you want to solve for it. So what you can do is, Hamiltonian is kinetic plus potential, right? So you can open it up using this formula, x t plus x v. So this way these properties will be helpful for you. Now the fifth property is, if we have a linear operator, it is going to always commute with any constant value. Suppose we have some constant value as c. So we have an operator a and we want to find out its commutation with any of the constant c, then it is going to be equal to 0. Commutation of any operator with constant is always 0. Sixth property says that any operator will commute with itself, that is, a is an operator and we want to find out commutation of this operator with itself, then it will be 0. Also, commutation of this operator with its nth power, any power, okay, nth power will also be equal to 0. So this is the next property. So far these are the properties of commutator operators which you need to remember. I have tried to give you as much tricks as I could give so that it would get easier for you to learn these formulas. So these are going to be very helpful for you when you're going to solve the numericals. So far that's it for the commutators. So we'll start with next topic in the next video. So far that's it for this video. Thank you so much for watching.